ladies and gentlemen, welcome to our 7th video for What Have I Become? As always, look at yourself in the mirror, take a selfie, and ask yourself deep down, on the tiniest of levels, what are you? Cells, molecules, atoms. What is life? What does it mean to be alive? The last time we got together, we focused on these two major problems. How do humans impact climate change? And how do toxins and pollutants affect our body? We have spent a lot of time thinking about this virtual lab and what it means for pollution and our bodies. What it means when something's acidic and basic, and how can acid be considered a toxin or something harmful to our body? And also, what does climate change and those toxins, that acid rain, have to do with each other? And we explored that a little. Hopefully at this point we have learned a good amount about problem 2 and 3. We're not experts, but we've learned more. So let's take a break from 2 and 3 and let's move a little ahead and spend a little more time again thinking about problem 1 and problem 4. So problem number 1 is what's happening inside our bodies when we're healthy or sick? And related to that is, do our cells have a degree in chemistry? Now, we've spoken a lot. We've talked about molecules making our bodies. We've talked about atoms making molecules. We've talked about our cells are made of molecules and our body are made of cells. So a lot of chemistry is happening. A lot of atoms bonded together, forming molecules and bigger molecules and our cells and eventually our body. But how does that happen? How are these atoms forming all these complicated structures and our atoms? Now just think about this. Watch this video. This was made by Harvard University. I'm just going to play it and then just take note of all the crazy molecules that are playing a role in the life of a cell. Everything you're seeing before you are different molecules of different shape and sizes, all playing a role in the cell. Look how complicated it is. All these structures dancing around in the cells, all these molecules of different shapes doing different activities. This is all happening in this complicated chemistry of your body. These are all different molecules of different size and shape doing different things for your body, creating the structure of your body, building highways, molecular highways throughout the entire cell. You have molecules changing shape or bonding to one another, breaking chemical bonds, making chemical bonds. Let's spend some time thinking about all these crazy molecules that make up our cells. And what does it mean? How can they ever form such weird structures in the body? Like this crazy protein molecule transporting materials in the cell. Let's begin. Let's start thinking about the basics of building molecules. So to better begin our understanding of cells, and all those amazing, complicated, confusing molecules inside the cell, to begin understanding them, we will today start exploring 2 new problems. What's happening inside our bodies when we're healthy and sick, and studying what kind of chemistry is happening in those cells. And we're going to better understand these problems 1 and 4 by doing a statement of understanding. This statement of understanding should be in paper form with you right now. But if you don't have this worksheet, maybe you're absent, or maybe you just need to ask Mr. J for it, so I'll await your request. This statement of understanding begins with a question: how do molecules form from atoms in our environment? How do molecules form from atoms? And we're going to do 5 observations. And when we're done with these 5 observations, we're going to come up with a hypothesis of how we think molecules form from atoms. Right now, go ahead and pause the screen and get these 5 observations down. Go ahead and copy them on the worksheet. Or pause this video and wait till you get the worksheet from me, and then just come back to this later and watch it. So go ahead and pause it if you need to, if you don't have this worksheet yet. Or you could just get a blank sheet of paper and follow along. All right, so let's get this done. Let's start with observation 1. Let's start learning about this problem, this mystery of how molecules form atoms. All right, first up, we have another PhET simulation. PhET is always there to help you. PhET from Colorado University. Right now, I put it to slow motion, and we have 2 atoms of oxygen. One is pinned down, it cannot move, and the other one is free to move in whatever direction that atom wants to. So right now, you can see on the x-axis is the distance between the atoms, and so you'll see the distance come closer. They'll come closer together, and you'll see it move more to the left as these 2 atoms get closer, and you'll see this dot move further away if they're further apart. Right now, all I want you to do is observe this atom in slow motion and look and see what happens between this atom and this one. What just happened? You can see arrows pointing towards one another. Did they move closer or did they get further apart? Well, judging by the graph dot moved more to the left, so they moved closer to each other. Why? Why did they do that? Well, let's think about this after a moment. But for now, let's just go ahead and rewind it. Let's put them further apart. Now, if I leave this right here, you can see that it's moving ever so slowly. They're separated, and yet they move towards one another. What causes them to do that? The forces that cause this are the same reason why they form bonds. In fact, if we just leave them to this, I can even move them closer together, and just look what they do. They'll stay together. They stay connected. They've formed a chemical bond. In other words, they've formed a molecule. Atoms, not all atoms, but at least these 2 atoms, these 2 oxygen atoms, have formed a bond. They want to stay connected. They have an attraction. Let's fill that out based on what we've learned so far. All right, we're going to fill this in. It's atoms have negative and positive, so we're going to do this, negative and positive charges that lead to chemical, and it's a connection. They hold together, so we're going to call it bonds. It says temperature causes atoms to blank. Let's move on to another simulation and see if we can study this. We're going to add some atoms here. Done. We're going to add some molecules here too. So we have equal numbers. We have 6 atoms and then 6 of this molecule that are made up of B's and C's. Let's see what temperature does to them. If I cool it down, if I lower the temperature, you can see that they slow down. And if I raise the temperature, they speed up. Now, we want to study these particles because we're looking for something. We're looking for this to happen. We're looking for an A to form a bond with B. Right now, that has not happened. There's none of them. But I'm going to heat this up more and cause them to bounce into one another. And we're going to see if we can't break this bond and allow the A atom to bond with the B atom and make a new molecule, form a new one. So we're going to do it till it happens. Did you see it happen? I'm going to pause this if I can. Doesn't look like I can. So let's see if we can just find it. There it is. I'm tracking it right there. There, we formed one. So a new bond was formed. You can see that they're moving quickly. They're hitting each other. And as they hit each other, we get different amounts of these. So right now we actually have more of this than single atoms. So as they run and collide, and as temperature heats them up, and right now they're just reacting, chemical reactions are happening, just based on them colliding with one another. So if they come into contact with one another and they move fast enough, we can get A to form a bond with B. There's the pause button. So you can see it happened here. They used to all just be single atoms, and now they've formed new bonds with B just based on collisions. coming in contact with one another. Here we go. It says temperature causes atoms to move fast or slow. Okay, and then you can see it says as atoms move faster, they collide. This is a collision right here. Here's a molecule, here's a molecule. They collide, and then it forms new bonds. So as atoms move faster, they collide and form new bonds. Again, we're trying to learn about this. How do molecules form from atoms? So we watched that. We watched a single atom form a new bond and create a molecule. So we're starting to learn more. We also know that they're attracted to each other because of these positive and negative charges. And that helps form a bond. As two atoms form a covalent bond because of their charge attractions from positive to negative charges. Let's do 4 and 5. That's another simulation. Let's move forward. So what I'm going to do is I'm just going to add some elements here. This is an oxygen atom, an element of oxygen, one single atom. I'm going to bring in a carbon. I just formed a molecule. They were attracted to one another, carbon monoxide. You can see they have a great three-dimensional structure. I like the ball and stick myself because it shows the chemical bonds as lines. These are triple bond connecting the carbon and the oxygen. Carbon monoxide, by the way, is pretty deadly. It can kill you if you inhale too much of it. We have carbon monoxide sensors in our home, part of our fire detectors in our home, so that we can make sure carbon monoxide gas isn't too common in the home and kill you. All right, let's add something else. Let's add a hydrogen. Hey, we got a hydrogen to bond to it. They're attracted. Let's put a hydrogen on the carbon, right? Let's do another hydrogen. Yeah, we just added it. Look at that. I just made a new molecule. These hydrogens were attracted to these two other elements, these two other atoms, and it made this word that I will not try to say. And you can see it has a three-dimensional structure, or the ball and stick I prefer. And you can see it looks just like that. Pretty cool, right? So far, all we've seen are that atoms are always attracted to atoms. Let's see if I can get it to do the opposite. You see, the hydrogen will not bond to this oxygen. Let's see if I'll get it to bond to the carbon. Nope, this hydrogen will not bond to the carbon. So it looks like atoms will not always bond. Let's see if I can add a carbon. A carbon bonded. Let's see if I can get another carbon. Nope, a carbon will not bond to this carbon. Will it bond to this oxygen? No, it will not. So atoms won't always bond to each other. Let's see if I can get a hydrogen to bond to it. Nope. So you can see atoms sometimes bond to other atoms, but sometimes they don't. You need a chemistry class to fully understand why that is. All right, let's move on to finishing our statement of understanding. It says atoms do, don't, or may form bonds with other atoms. We now know that it's may. So let's change the color to a nice bright green. May form bonds with other atoms. Very good. It says atoms can or can't have different bonds. Let's think about how we want to finish this sentence. So we're going to say they can. So atoms can have different, let's say, number of bonds and shapes and sizes. So atoms can have different numbers of bonds, and let's clarify this, and form molecules of different shapes and sizes. All right, let's keep moving so we don't run out of time. It says our hypothesis is, I think atoms form molecules by attractions that bring them together to form many atoms bonded as a molecule. That's my hypothesis. And now on your own, I can't help you with it, but you got to create a model, just like this is a model, this is a model, this is a model. Use these 5 observations and this hypothesis to create a model. I'll talk a little bit more about this in the next video, but for now, start thinking about what you would draw